Hello.
Hey Jafri.
Hi, how are you?
Good, good. I just loaded up your thermochemistry PDF, so
Okay, that's
I got it on my
okay.
screen to
That's
the left.
yeah, that's good. Okay.
I remember this was the section in General Chemistry 1 that gave me a hard time to begin with, and it was what motivated me to find a tutor, and that's how I came across
Okay.
seeing your ad on Craigslist.
Okay. So,
Yeah, this is the one I got.
hmm. So
Trying to.
let's start first the problem which you send me the numbers
Yep.
because you open that one. I'm going to open that one. Tell me what question number.
Oh, it should be 6.17.
6.17. Hold on. This one, a gas expands in volume.
Yes, a gas expands and does PV work on the surroundings equal to
Oh,
325 joule.
okay. Gas expands and does PV work on the surroundings equal to 325 joules. At the same time, it absorbs 127 joules of heat from the surroundings. Calculate the change in energy. Okay. In this chapter, the important thing is the formula, of course, is important, but the other thing is the sign of the values because you have to put those signs. They are not going to give you positive or negative sign.
Mm-hmm.
So let's start with this question 6.7 and
1.17. 6.17.
6.1. Yeah,
Yeah, you got it.
17. And first make a data. The work done to the gas expands because the gas is expanding.
Mm-hmm.
Gas is expanding. Now let's go to the problem because if you go to in this the formula of this one. So you look like here. Which one is here? The formula. No, the first law of thermodynamics formula. The delta E is equal to Q plus W. Can you see this one?
Yes.
The delta E is equal to Q plus W. But the important thing is not only the formula, but also the sign.
Mm-hmm.
Q is the quantity of heat, work, delta E this one. And the sign is when it's going to be positive, when it's going to be negative. So look here in this case. When work is done on the system, that is compression, work is going to be positive. So whenever there is a compression, volume is decreasing, we are going to take the sign as positive.
Mm-hmm.
And the work is done by the system, expansion. In that case, work done against surrounding and that is going to negative. And that's the confusing thing is in physics and in chemistry, they use an opposite sign because they use a different type of formula like that one. So I have to, when I'm teaching physics, I have to change the my whatever I'm saying right now.
Yep. Yep.
So here it is, compression means positive, the work is positive. Expansion means is going to be negative. So expansion is work done by the system because when the system is working, it's spending some energy. So that's why negative. When
Okay.
something is happening like compression, so we are adding the energy into that one in the form of work. Q is positive if the heat is absorbed or gained by the system, or in other words, lost by the surrounding. Q is negative if the heat is lost by the system or gained by the surrounding. And the same thing is delta E. If the temperature is constant, delta E is zero. Now let's go back to the question here. This one,
Mm-hmm.
this 17 one, 6.17. Now you tell me like in this problem, uh, a sample of, no, we are doing this one. This 325 joules.
Mm-hmm.
What is this?
It's. I think it's gonna be negative 325 joules because it's if it's work On the surroundings.
And this is W, am I right?
W.
And because it is a compression, it's no expansion, sorry. Expansion, so you're right, negative.
Expansion.
We are going to take the negative because the gas expanded does work on the surrounding, So it is negative. So actually the work done on the surrounding means work done by the system. So always remember these two, same meaning like this one. So whenever they say work done on the surrounding, it means what?
Expansion or...
Yeah, it means work done by the system. So suppose it, if you are doing the work on the surrounding, it is system is doing the work by the system. And the value we are going to take negative, and that is expansion.
Got it.
So now we know that's negative. Now what next? At the same time it absorbs. So what is this? 127 joules is what?
At the same time, it absorbs 127 joules of heat from the surroundings. Calculate the change in energy of the gas. So, my first thoughts are it would be like negative 325 joules plus 127 joules, and then the answer.
You're right.
The answer would
be.
Yeah.
What is the formula? Okay, this is the Q. Am I right? Q. And this is absorb means positive. What is the formula for delta E?
So we have
first law of thermodynamics. If you see the formula for first law of thermodynamics,
delta
is
E equals Q plus W.
Q plus W. Q plus W. In physics, actually, they take Q minus W, something like that. That's why they have like a different style of doing the problem. So here it is delta is equal to Q plus W. So now I am putting 127 because it was positive. Plus what?
Plus negative 325.
Negative 325.
Joule, yep.
Joules. Both of them are in joules. So 127 minus 325. And what you will get?
Negative 198 joules.
Negative 198 joules. It means the internal energy is decreasing. Joules. Now I'm asking another question. They are not asking, but I am asking. Okay. Internal energy is decreasing, right?
Yes.
So if it is decreasing, what you expect? Temperature is going to increase or decrease? Temperature of the system.
The temperature of the system would decrease, right?
Decrease, because temperature depends on internal energy. If the internal energy is increasing, temperature is going to increase. If it is decreasing, temperature is going to decrease. Okay?
Right, because the temperature that increases is the surroundings, right?
Yeah.
Okay.
No, we are talking about temperature of the yes. Surrounding temperature is increasing. In system in temperature is decreasing.
Got it.
Okay. Now, next let's go to.
Is it you want to advance to the next one?
Yeah. Which one is next?
6.18.
6.18.
18.
18. Okay. The work done to compress the gas is 74 joules.
Okay.
Now, whenever we are reading this, you tell me the data. They are not going to give you the sign. You have to write the sign by yourself. Determine the sign by yourself.
Yeah.
So 6-18 question. Now what is this?
Okay, it's saying the work done to compress a gas is 74 joules. So I know it's 74 joules, but to determine the sign, we look at when work is done on the system, compression, work, W is positive. So
you're right.
W is positive 74.
What next? What is the 26?
As a result, 26 joules of heat is given off to the surroundings. Okay. So that means Q is equal to 26 joules, and I have to just think.
What is the sign of Q?
The sign of Q. Q is negative if heat is lost by the system or gained by the surroundings.
Yes.
Okay.
Yes. Because they're saying given off to the surroundings. So the system is giving, so it is losing. So I'm putting minus.
Yep. So that means
Calculate the chain energy, delta E.
Yep,
We already know the formula. Delta E is equal to
Q plus W.
Q plus W. And plug in the value. Q is minus 26 plus 74, and we will get what?
And we're getting 48 joules.
48 joules. So there is an increase in energy of 48 joules because it's a compression, not the expansion. So whenever there is a compression, like something is coming into the system, so energy is increasing. It's clear?
Yes. Yep.
Okay.
All right.
So basically what happening, you can consider like, suppose you have an account, okay, in the bank, and suppose you have in your account, you have some money. Now you are depositing in this case $74, and you are spending $26. Now whatever that dollar you have, suppose you have $100. So how much is going to increase here? You are putting $74
We're putting $74 in, so to
and taking out 26, spending 26.
so it would be
So how much increase? Look, 174,
40,
right?
Yeah, it'd be 174 minus 26.
Minus 26,
So 148.
148. So basically you have increase of 48, going 100 to 148. Am I right?
Yes.
48. The same thing is here. When is a compression work done on the system, it's a positive. It means you are depositing some money into your account. And Q, like if it is negative, it means you are spending some money. And now how much is the profit is 74 minus 26, 48. Is clear?
Yes. Yep.
Now what next?
It's 6.25.
6.25. Okay.
Yep.
Let's see this one.
Yeah, I got the book over here.
6.25. Determine the amount of heat in kilojoules. Also looking like what they are asking in kilojoules.
Or it should be that one there is 6.26, but we got to do 25. It says the first step in the industrial recovery of copper from the copper sulfide ore.
Oh, so we have to do the 25.
25.
Okay. The first step in the industrial recovery of copper from the copper sulfide ore is roasting. That is the conversion of CuS to CuO by heating. Okay, question is to calculate the heat evolved in kilojoules per gram of CuS roasted. Okay. Now look here, we need the atomic mass of Cu and S also.
Okay.
Can you give me the atomic mass of copper?
Yep.
Otherwise the molecular mass of CuS?
Yep. I got the periodic table here. I can calculate it. Cu, I'm taking. You want to take 64?
Yeah, you can. No, how much is that one? If it is closer, then it's okay.
It says
63 point, how much?
0.546.
Okay, so 63.546. Let's take this one. And how much is the sulfur? 32?
Sulfur is 32. Yeah.
Okay, so we can take this whole thing. How much is that one?
Equals 95.546 gram per mole.
95.546.
Yes.
gram per mole. Okay. So we have this thing, information. Now, according to the equation, if you see in the balance equation, there was a 2 CUS, am I right?
Yes.
Okay, plus 3O2 and then all over is going to be 2 CuO plus 2SO2 gas.
Yes.
Basically, they are, and the delta H given here is how much?
Negative 805.6.
805.6 kilojoules per mole. Now, this is for 2 mole. This is for 2 mole. And 2 mole means 2 times 95.546. So, otherwise, I'm going to write like this in the stepwise. I am writing 95.546. No, not sorry, not like this. 1 mole. 1 mole. Oh, sorry, 2 mole. When you burn 2 mole, how much energy is released?
95 point. I'm sorry. The energy released is negative 805.6
Kilojoule. Right. Now, if I burn 1 mole of CUS, sorry, this is also CUS, is equal to how many gram?
We said 95.546 grams.
94.546 gram
95.
of CUS. So mole I cancel this one, and now I have the grams. Now I want to get like, this is like 1 mole is equal to that one, that much. So what I have to do is I have to calculate per gram. So I think I put wrong way. This is not going to work. I'm going to put opposite. 8 to 5.6 kilojoules for 2 moles. I'm writing like this. 1 mole is equal to how many gram?
We said 95.546.
95.546 gram CUS. That's it. This is cancel this one because I did opposite. How I know that I am doing wrong? Because I was not getting kilojoules per gram. Look, I am getting gram per kilojoules. Can you see the unit?
Yes.
Here, the wrong thing, because you also have to learn from our mistakes. Okay.
Absolutely.
Mole was cancelled, but what the problem here I saw my unit is going to be at the end gram per kilojoules, but they are asking kilojoules per gram.
Okay.
So I need the gram at the bottom and kilojoules at the top. So I just did reverse then. So I can get, now look here, mole cancel, and now the unit I can see, I will get the kilojoules per gram. So it means that's I want. So it is okay now.
Okay. You want me to do it out in the calculator?
Yes.
Negative 805.6 divided by 95.546.
And just give the 4 significant figure. What is your answer?
Yeah, for 4 sig figs, negative 8.432.
No, I am getting 8. Yes, you are right. Oh. Wait a minute.
No, I did something wrong. I'm sorry.
What is I am doing wrong? Do something. 8 to 5.6 divided by 95.546.
No. Yeah, negative 4 point.
I am getting 8.43, but answer I see different. I am getting minus 8.43 kilojoules per gram. But the answer on your book, why it is minus 805? Oh, that's not the answer, sorry. That's the delta H value. Okay. We are right now. It's clear?
Wait a sec.
No, no, I was thinking that the answer, but that the delta H value which we have used. So that's correct. We got the answer. It's clear?
Hold on a minute. I'm getting negative 4.216.
4315 something, but I just put 432 like this. Four significant figure. Yes. Is clear?
So okay, so it's half of this one, right?
Yes.
Half of this, negative 8.432.
Yes.
Okay.
And it's not half first because that was for 2 mole. But they are asking per gram. Okay. So it is, you can say, 90 approximately 95 times less. Because if you multiply again by 95.546 and 2, you will get again the same value delta H.
Okay. Yeah, I'm looking at the solution manual, and it's saying that it's calculating the heat evolved exactly like this, but they're not using the negative sign. So then
Yeah, negative.
the answer that they have it in bold is 4.213 kilojoule per gram CUS.
Oh, no, no, no. No, 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 that's right. Okay, what mistake? Uh, we are doing what question we are doing? Okay,
6.25.
okay, say that's they are right.
They
Why?
just they just had
Look the problem. No, no, that's the they are right because if you looked at it, when the equation is 2 CUS, but the delta H value they had given is per mole, not for 2 mole.
Mm-hmm.
It's not the kilojoules. It is kilojoules per mole. Can you see the delta H value?
Yes.
So I thought because it is just the delta H, not the per mole. So I took 2 mole because in the equation it was 2 CUS.
Mm-hmm.
So that's why. But here it is only 1 mole. So now I don't have to put the 2 here. I have to put what? 1 kilojoules per mole. It's clear? And now I am just converting mole into gram, and then you can see what you will get now. Half of that one. Look
No,
this one.
no, no. I'm getting
Kilojoules per mole. 1 mole is equal to this many gram. Hold on, just I'm writing. 95.546.
what you had was right. This
3 to 5.6. No, wait a minute, I'm just looking for something. Divided by 95.546. Now I'm getting 5. 8. Actually, let me explain this thing. The 2 is looks good, am I right?
yeah, the two is good.
Oh, okay, but the problem they had made a mistake. Tell me, I'm going to tell you this thing. If you read the delta H value, what is the delta H value they are writing?
Negative 805.
I'm writing the equation here. 2 is CUS. You can also tell this to the teacher. 302. Okay. The Chang is doing mistake. You can write the letter to the Chang. Okay. The thing is CuSO plus 2SO2. Okay, equation is this one. Am I right?
Yes.
Okay, either they have to give us delta H value minus 805.6 kilojoules. They don't have to write per mole here. Because if they write per mole, then it means it is for 1 mole, not for 2 mole. Then why we are dividing by 2? Then we don't have to divide by 2 because already per mole. Is it clear?
Yeah, you're right.
So they don't have to write per mole here. If they are thinking it is for 2 mole, for the whole equation. Normally when they write, if you look the other books, any other book, they will give you the problem like when they give not the mole, they will write without per mole. Is it clear? But if they write per mole, it means we don't have to put the 1. So they made a mistake here. So actually the
Yeah,
mistake is they don't have to put per mole here. Then now it is okay. Now we have to put 2 and you will get the answer.
wow.
But that's a mistake, and I hope that even the other one is going to be the same mistakes, looks to me, in the Chang's problem like this one. So what is the answer in previous case?
Yeah, it's so strange. No, it says the answer in the book is done exactly like this. The 805. It says the answer is positive 4.213 kilojoule per gram CUS.
4.213.
213.
Okay, that's 215 something. Okay, that's depending on how much they are using. Okay, in my case, I'm getting 6 something like that. But that's okay. Kilojoules per gram. The problem is they don't have to write kilojoules per mole. That's wrong. If they are putting it for 2 mole, and I think the same mistake maybe they are doing in this one, because normally we don't write this thing. I will show you one problem from any other book. Maybe I'm going to send you some. Let me upload something. So they don't give like this one per mole. They can give you, but in that case we don't have to divide by 2. Okay, what next question?
Yeah, it looks like the next one is kind of similar.
But I will recommend to go your teacher and just point out this thing.
Yeah.
That if it is kilojoules per mole, then we don't have to divide by 2. But it means it is not a per mole. They have wrong here. Because what the formula is, if you write kilojoules per mole, if already kilojoules per mole, so it means just you have to write 1 mole is equal to molecular mass gram. Am I right?
Right.
Then you don't have to put 2 here. So basically they are giving, they have to write without per mole. Okay, do you have to do 6.26
yes.
or not?
Yes, I do.
I think they have done the same. Maybe it looks like that.
Yeah, it looks
because
like
they don't have to write per mole. If they are writing the per mole, then we don't have to divide by 2. So let's do this one.
Okay.
6. Assuming that it is not per mole, just like the previous case.
Okay.
6.26. So I am writing like 2NO plus O2 gives 2NO2. And I am writing delta H value, but I am not putting per mole. I am just putting 4.6 kilojoules. I am not using the per mole. I will write, but cancel this thing.
Yeah.
Okay. And now what I'm going to do is amount of heat given off when that many grams. So they are asking amount of heat, Q, amount of heat. Sorry, not Q, delta H, sorry. Delta H for 1.26 times 10 to the power 4 grams NO2. Okay.
Okay. So let's see. I'm gonna put dimensional analysis up.
Okay, now let's try this one.
Okay.
This question.
All right.
It's very simple. You can, if it is not a mole, we can directly do this thing. I can say like per gram is equal to delta H per mole. delta H per mole
Mm-hmm.
divided by molar mass. But otherwise, if I want to go step by step, I can say minus 114.6 kilojoules per kilojoules. Not I'm not writing per mole. Okay.
Mm-hmm.
And now I'm and this is for 2 mole or for 1 mole. I will write this. I'm going to write for 2 mole. Okay.
Okay.
Because there is 2 NO2. 2 mole NO2. And now I'm writing 1 mole of NO2 is equal to how many grams? What is the molar mass of NO2?
Okay. I'm doing
And 14
14.2007.
plus 32,
Yep. 46.
46. I'm just writing 46 gram NO2. Okay. So mole cancel and I will get 114.6 divided by 2 and divided by 46. My answer in this case I am getting 1.246 kilojoules per gram, sorry.
Yep.
Per gram. And the answer is this one.
Let's see. They got in the book 1.57 times 10 to the 4 kilojoules.
Sorry. Because they had given the quantity, am I right? They are not asking per gram. They are asking for this one, am I right?
Yes.
And down you have to do it like this. Sorry, but you have to do one more step. Here it is 1.26. I forget this one. Gram.
Oh yeah, we just have to multiply it now.
Yeah, so gram cancel, and now you will get the kilojoules only. So now let's do this one. 114.6 times 1.26 exponent 4 divided by 2 divided by 46. What you said? What is the answer? 1.57.
Yep.
569 or 570 you can say times 10 to the that's it.
Yeah.
That's the answer. Kilojoules.
In the book, like it says 1.57 times 10 to the 4 kilojoules.
Oh, you're right, because I have to adjust this one. Because actually it was 15695.21. If I round it, I will get 1.570 times 10 to the power 1, 2, 3, 4. 10 to the power 4 kilojoules. Am I right? And the unit is kilojoules, not the kilojoules per gram. Am I right? What is the unit they are giving you?
They're giving us kilojoules per mole.
Per mole? Answer. I'm asking answer.
They're giving us kilojoules.
Yeah, that's correct.
Yeah, I'm
The
just.
thing is, the mistake is they are giving the wrong thing. They don't have to write. In all the cases, I see like the same thing. Maybe I'm going to write the Chang, this thing. This is wrong. You can write this thing. You can go and ask your teacher also.
Yeah,
Tell your teacher.
I got a different calculation. I wasn't doing it right, so I'm getting on my calculator. Negative 1569.52.
Yes, you are right. Negative, because I forgot the negative.
But
you're right.
It's like, let me see. But if it's 1.57 times 10 to the 4, that means it's 1, 2, 3.
I round it because 15695. Because I am rounding it, removing the 5, so I put 10. 10 means 0, and then 6 becomes 7. And because I need 4 significant figures, so I took minus 1.570. Maybe that a little bit answer difference is maybe they are not taking 46 because I'm just rounding it 46. You can go back and check if you want. Yesterday you was doing, day before yesterday I think, online calculating the molecular mass. So maybe a little bit difference is going to be here.
Yeah, I must be doing something wrong. Cause yeah, let me. Because in my calculator, this is the answer that it's showing me right now.
This one, yeah. Try. I'm just uploading something right.
9.51 or 5.21739. And this answer right here is not equal to 1.570 times 10 to the 4, right? Because 1.57.
What is your answer? 1 point?
No,
your answer is this one?
Yeah, this is what my calculator is showing me. So that's like
1.5.
That's like 1.57 times 10 to the 3, not times 10 to the 4, you know? So I don't know what I'm doing. I'm trying to figure out what I'm doing wrong.
No. Let me double check this one. Maybe I have to double check. 6 times 1.26 exponent 4 divided by 2 divided by 46. My answer is I'm getting 15695.2. Let me have a double check here. Oh, power is 4. So everything is okay. I am getting, like, my calculator is giving this answer. Let me have a write this thing. 15695.2 something. Is your answer is this one? But you are saying decimal is coming after 4 digits, am I right?
Right, yeah, I'm trying to calculate it again.
Oh, you did everything the same number on the calculator?
I just used another calculator and it's coming out to what it should be. Yeah.
Okay, let's do again together.
Yeah.
Press 114 minus 114.6.
Yep.
Then multiply 1.26 exponent 4.
Mm-hmm.
Then press divide 2. Again press divide 46.
Yep.
And then press equal to.
Yep.
And press SD so you can see what number you are getting.
Yeah, negative 15695.217.
Yeah, that's the same I am getting.
Okay. And so when we report the answer, we have to report it as like
4 significant figure if you want to scientific. So I am moving this one to 1, 2, 3, 4. So I am writing 1.5, and because I am dropping 5, so I am increasing 9, 1. So it will become 570 times 10 to the power 4 kilojoules. That's it.
Yeah. All right.
Is it clear?
Yeah. I just have to remind myself for these type that not to include the negative sign. Like when I'm given the answer, because it's asking for the amount of heat. So instead of putting like what the calculator the calculator reports it as a negative value, but I need to report the answer as a positive value.
Why they are not giving? I'm going to tell you. Because look, read the starting thing again. Determine the amount of heat in kilojoules given off, because they are already saying given off. So given off means it's a negative. So instead of, if we say minus and again say given off, it is negative double.
Got it.
That's why.
Okay.
It's clear?
Yes.
So if they say given off, then you just don't put the negative.
Got it. Okay. Thank you. Yeah, I'm gonna yeah. All right. Yeah, I'm gonna open up a web calculator so I can faster get the molecular mass.
What next?
It's saying 6.33.
6.33. Okay.
for piece of silver mass.
A piece of silver mass, 362 gram, has a heat capacity of this. What is the specific heat of? Okay, what is the meaning of a specific heat? A specific heat means like a heat capacity per gram, you can say. Okay,
Okay.
I will show you the formula first here. The specific heat. Look, this one is specific heat. Q is equal to S delta T, where S is the specific heat. And if you multiply S by the molar mass, it will become molar heat capacity. That's the thing. M is equal to MS delta T. M normally we take in grams, and specific heat normally we take in joules per gram per Kelvin or per Celsius. You don't have to change into Kelvin into Celsius, Celsius into Kelvin.
Okay.
Same thing. So let's go back here and we try this thing. 6.33. Okay. Let's write the data. You tell me the data.
Yeah, a piece of silver of mass 362 grams.
So mass of silver. How much is this one?
362 grams.
62 gram. Okay.
It says it has heat
capacity.
Yeah, 85.7 joules per degree Celsius.
How much?
What is the specific
25.7.
Yep. That has a heat capacity.
Okay. Joules per degree Celsius. Okay, what else?
It asks,
what is the specific heat of silver? So they are asking S. Specific heat of silver. I can write like this one, and I'm going to back to the formula sheet. What is the formula I give you like here?
It says Q equals MS delta T.
MS delta T. Now I'm writing again, going back here. In this case, Q is, I am writing. So actually this is Q over T. Q over what? T. Per Celsius they are giving it. So I can say Q is equal to 87.7 joules, and because per Celsius is mean that T is delta T is 1 degree Celsius. So like 1 degree Kelvin, 1 Kelvin. Because for delta change, you don't have to change like a 273, because change is same in Celsius or Kelvin. So don't add 273. And now the M is, we already have 362 grams. And I'm writing Q is equal to MS delta T. And they are asking the specific heat like this one. So let's do.
Wait, how do we know delta T is 1 degree Celsius?
Because they are using the word heat capacity is 85.7 joules per Celsius.
Oh, okay, per 1 Celsius. Okay. Okay.
Per Celsius. For this many grams. So per Celsius means it is 1 degree change they are giving.
Got it.
Now I'm plugging the value because I need the S. Can you rearrange this thing?
Yes. S is equal to Q divided by M and then divided by delta T. So S.
Okay, so I'm just.
Yep.
87.7 joules. M is 362 gram. Delta T is how much?
Delta T is 1 degree Celsius.
1 degree Celsius or 1 degree Kelvin, same thing. So if you solve this thing, what you will get?
Typing it in. 85.7 divided by 362. So it's 0.2367.
No, 236? No, I'm getting 242 something. Let me double check, maybe I'm wrong.
No, I just didn't round it yet. So 0.237?
No, I'm getting 0.24226, something like that.
Oh, it's let me see. I think 85.7 is the
Oh, no,
specific
no, sorry.
capacity.
I made mistake. In the data I put 87 point something. That's why. Okay. Sorry, it's my mistake. It's 85.7.
And that's
85.7. I put 87.7.
so is that
No,
joules
you are
per
right.
gram?
And how much we are getting? 0.237. And the unit is going to be joules per celsius. Joules per gram per Celsius. Look, joules per gram per Celsius. Clear? And we can also do this thing even without using the formula. I can go step by step and I can get the same unit. Look, I'm doing gateway. I'm going without formula 85.7 joules. They are saying for how many gram they are saying? For 362 gram, right?
Gram? Yes.
And for per Celsius. Other per Celsius. Per Celsius. I'm going to write like per Celsius. Now I'm going to do it like this. They're asking per gram. They're asking what? Per gram. So the specific heat is, you can just do it for, divide by that one, and that's it. You can write for 1 gram. And same thing you will get. Okay? But that's better. You can do it like this. Any next question?
Okay. It says 6.35.
6.3.
Yep.
6.35.
Calculate
Okay.
the amount of heat liberated in kilojoules. Okay.
The heat liberated. Okay. What is the meaning of heat liberated?
The heat that's formed or given off from as a product.
Given off. So because they are already saying liberated, so it already means negative. So if it is
Like
negative, you are getting the negative answer. Don't put, because liberated means negative. Okay, it's coming. So don't use double. Liberated and negative is like, it's just like 2 negative. Okay, now in kilojoules from 366 gram of mercury when it cools from this. Okay, but I need some information for solving this question. Do you have the chart in the book?
Yeah.
What we need is, I will show you. I will write this.
Well,
mercury.
is that standard enthalpy or something? Or no?
No, I'm telling you. Okay, calculate the amount of liberated in form this gram. How many grams we have? 366 gram.
Yep.
When it cools, what is the temperature? Yes, 77 degrees Celsius in the beginning. Right?
Yes.
I need the specific heat of this one, mercury.
Okay. I'm gonna check. Okay, let's see. You need to give me more. Okay, sorry it's taking me so long.
No problem.
Mercury is Hg, right? So so Hg liquid, is it? Let's see.
Which one? Hg. This mercury is liquid, yes.
Alright, so Hg liquid, it says S is 77.4 joule per Kelvin per mole.
Okay, for mercury. Can you give me again?
Yep,
77.4
77.4.
joules per Kelvin per mole.
Yeah, it's
So, but that's not the specific. I need the joules per Kelvin per gram. Let me have a check this. Okay, otherwise we can divide this by molar atomic mass of mercury if we don't have that. It's okay, let me have a double check this one. Because specific unit is not per mole.
okay.
Mercury. Joules per kilogram per gram per Celsius. It's 0.140. Do you have that thing or not?
I had to look in the appendix at the thermodynamic data, and it gave it in joules per Kelvin per mole. So I'm gonna just try and Google it.
Okay, no problem. Okay, no problem. Give me that data. Don't worry. Give me that one, whatever you have. You told me 77.4, am I right?
Yes, that's it.
Okay, because this is per mole. We want per gram. So what we are going to do is just divide this by atomic mass of mercury. What is the atomic mass of mercury?
.200.59 grams per mole.
77.4, 200.59.
Yep.
Okay, multiply this one. Or divide this. Sorry. 77.4 divided by 200.59. And I am getting 0. What is your answer here?
I was just trying to write the dimensional analysis, but yeah, I'm getting now 0.385.
5/8, so I'm rounding it to 0.386. Is it clear?
Yeah.
So if they are giving you joules per Kelvin per mole, then I can get this joules per Kelvin per gram. Now I'm going to use this one to calculate this one. I'm going to use like how much they gave us?
366 grams of mercury.
So I am writing Q is equal to ms delta T. Now Q we have, sorry, they are asking Q. M we have, how many M we have?
366
366. Okay, so I am writing 366. The S we already calculated 0.386. And delta T is the difference, temperature difference, 12 degree minus 77. So I'm getting minus 65. Minus 65. And now calculating all of them, 366 times 0.386 times 65. And I am getting minus 9182.94. Rounding to three significant figure, I can say minus, but because they're already saying how much is liberated, so just already using the liberated, so skip that one. So heat liberated, because I'm using the word heat liberated. So I'm rounding it to three significant figure. I can say 918 roughly 0, or I can say 9.18 times 10 to the power 3 joules. And if you want kilojoules, it's going to be multiplied by divided by 1000, you will get 9.18 kilojoules. What is the answer?
Let's see. For this one, they're given the answer as negative 3.31 kilojoules.
3.31, 3 point,
It says
what is your, they given
it says negative.
3.31.
Yeah, and
They are using the word negative also.
yeah, it's really strange, and it says to see table 6.2
No, no, no,
in the
hold,
text.
hold on, just hold on.
So I'm going to that table.
No, 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 I am going to specific it, I am checking from the online. The specific heat of mercury. Maybe they are not giving us the correctly. It is 0.140. His value is what? 0.140. If I use 0.140 instead of 0.386, which I have used, 140. So now let's see what I will get. 366 times 0.140 times 65, and I'm getting, yes, now you are getting the same answer which you are saying. I am getting this one, joules. And if you want kilojoules, move the decimal 1, 2, 3, and you will get 3.33 kilojoules.
Okay.
But in that case, the specific heat value is not this. The specific heat value is 0.140. What is the value?
Yeah, 0.140.
For mercury, it is S is equal to 0.140 joules per gram per Kelvin or per Celsius, same thing. This is. But then why they are giving you this one, 77.4? That's the wrong then. It is a specific heat or something else.
I'll write it with my. I'll write it with my pen. All right. So I referred to. I didn't. Yeah. I was looking at Appendix 2. It says thermodynamic data at 1 atmosphere and 25 degrees Celsius. And it says...
Okay, is this...
It gives 3 values. It gives delta HF, delta GF, and then it gives S. And so I was like, okay, S is...
okay, no. That S is not a specific heat. That S is entropy.
Okay.
Whenever they give the delta H, delta G, the another one S is delta entropy.
Okay.
That is not this one. That's why we got the wrong answer in the beginning.
Okay.
This is the correct answer is not this one but 0.140. And now you will get the correct answer.
Got it. Yeah, I was having trouble finding the table, and I found the table that was in the chapter.
Okay. Okay, no problem. We can get from internet. But what is the, are they using minus sign or not in the answer?
Yeah, they are. I don't know why they are, but they are. It says...
They don't have to use, because if they are saying heat liberated already means negative.
Yeah.
So if you skip negative sign, then do it like this for the safe side. But first write 3.31, write both of them, okay? Joules, kilojoules, okay? And then you can write like heat liberated and now I'm skipping the negative sign because the negative heat liberated means negative. That's why. So put both things. In the one case, put negative sign and then write or heat liberated is equal to this. So in
Okay.
case if they detect mark, you can go back.
Got it. Okay.
Okay, what next question?
Let's see. We got 6.37.
6.37. Mhm. Okay, read and tell me the data.
Okay, we got. Okay, the data is coming here. 0.1375 gram. 0.1375 gram of solid magnesium, Mg,
Mg.
is burned in a constant
So this
volume.
is the mass.
The mass.
I'm writing M. Okay. Constant volume bomb calorimeter.
Yep.
That is heat capacity of. So it is a calorimeter capacity you can say. What is that one?
3024 joules. 3024 joules per
Joule. Not
Celsius.
per se. In this case, you will not see the gram. Okay. For the calorimeter, bomb calorimeter. The temperature increases, the delta T is positive or negative? What I have to write? Positive or negative?
Negative.
No, they are using the word increases. An increase is positive, decrease is negative. Is clear? Increase means what?
Hold on. The temperature
Positive.
increases.
Decrease means what? Negative. So because here they are using the increase, so just positive. Read the further what they are saying. Calculate the heat given off by burning. Now again they are using the word heat given off. So I don't think we have to use the negative sign. You can get the negative sign, but at the end you can write heat given off without negative sign.
Okay.
Okay. Calculate heat given off magnesium in kilojoules per gram. You have to give the answer in 2 units. Kilojoules per gram, and also you have to give the answer in kilojoules per mole. Both answer they need. Okay. So let's start with this.
Okay.
Reading again, the 0.1 gram sample of sodium is burned in a constant volume bomb fluid that has a heat capacity of this. The temperature increases by this. Calculate the heat. Okay, now I will go back to the calorimeter. Constant volume calorimeter. Can you see this one?
Yes. Q of the reaction.
I will make it clear. Constant volume calorimetry. Q of the reaction is equal to minus. This is the
Constant.
calorimeter's capacity constant. Time delta T, the change in temperature. So this is the constant for each. You write the minus sign into delta T change in temperature. So I am using this formula for calculating this. We already have C is here. And what is the formula? Q reaction is how much? Minus C calorimeter time delta T. The minus calorimeter is how much?
Is it 3024?
3024 joules per Celsius, and the change in temperature is 1.126 degrees Celsius. So, 0. Okay, they are asking per gram per this. Okay, no problem. Now do the calculation. What you will get?
Okay. Negative 3024 times 1.926. Okay, I'm getting negative 3405.024.
Negative 3405.02. Okay, and the unit is going to be joules, right?
Right.
They are asking what? In kilojoules?
Let me see.
Yeah, they are asking. So let me convert into kilojoules this one. Okay. How we can convert this into kilojoules? You move the decimal 1, 2, 3. What you will get? Minus 3.4. How many units we have to use? 4. So 3.405 kilojoules. That's the answer. And now, because that's not the answer, because they are saying per gram, they are asking per gram. So I'm writing this one here. 3.405 kilojoules, and this is for how many grams? In the beginning they already have gave you 0.1375. And look, if you look the units, you don't have to do anything else. Your answer is already going to be kilojoules per gram. Check this one. 3405 divided by 0.1375, and what is your answer?
24.76.
No, maybe I'm wrong. Let me double check. 3.405 divided by 0.1375. Yes, 24.7, am I right?
Right.
76 and minus. Are you getting the same answer?
Yes.
Okay. This is kilojoules per gram. Now I'm going to do per mole. This is for grams. So per gram is, or I can go directly from there, from the beginning. 3.405 kilojoules is present in 0.1375 gram. Now I'm writing what is the molar mass of, what is the atomic mass of magnesium? I think 24.3. Just double check.
Yes, you're right. 24.3.
24.3 grams mg. 1 mole of mg is equal to that many gram. And look here, I don't have to go further. Gram of mg cancel. And now my answer is already in kilojoules per mole. That's they are asking. So just use your calculator. Minus 3405 divided by, minus 3.405 times 24 1.3 is 3.405 times 24.3 divided by 0.1375. What is your answer?
I'm getting negative 601.76. Negative
Maybe I'm
600.
something wrong. Maybe I'm, hold on just a moment. 3.405 times 24.3 divided by 0.1375. Yeah, negative 601 point something, right?
Right.
601.75. But as they are already saying in the problem, that calculate the heat given off. Because the given off, then we don't have to write the negative sign. I can write like 601.75 kilojoules per mole given off.
Yep. Yeah, you're right.
Because given off means negative. The same thing you can do it here. If you want to write given off, you can use 24.7 kilojoules per gram given off. Okay?
Yes. Yep. This.
What next question?
Yep.
What next question?
37. I'm sorry, or we
That's
just
what we did.
51.
51.
51.
Mm,
Saying calculate the heat of decomposition.
Okay. So we calculate the heat of decomposition for this process.
At
at
constant
constant
pressure.
pressure. Oh, okay. Look up the standard enthalpy of formation of the reactant and products in table. Now you have to tell me from the table that one.
Okay.
Okay. I am writing the here. CaCO3 solid. And look the delta HF formation value. Give me those please value. CaO solid and also carbon dioxide gas from the
Okay. This
mm,
the CaCO3 standard enthalpy of
solid.
formation.
Mm.
I'm trying to
How much?
delta HF, right?
Oh, yeah. What is the value?
Okay, it's negative 1203. I'm sorry, negative 1206.9.
What is the unit? Kilojoules per mole?
Yes.
Okay. What about the next CaO?
CaO is negative 635.6.
635.6
0.6. Yep.
kilojoules per mole. Okay. What about carbon dioxide? Negative
CO2 is negative 393.5.
Now look, the heat of enthalpy of formation is always negative. Exothermic process. We got all of them. And now they are asking the decomposition process, like the you can say enthalpy of reaction. So I'm writing here. CaCO3 solid change into calcium oxide solid plus carbon dioxide gas. These are your products. This one is reactant, right?
Yes.
Now for delta H of the reaction, I can say RXN. Otherwise you can say decomposition in this case. Is equal to, because it is breaking into calcium oxide and carbon dioxide. So look here, this decomposition is the forward reaction, right? Calcium carbonate is breaking into this thing.
Yes.
That's decomposition. So it means that you are calculating the enthalpy of reaction. It is the same as in this case decomposition enthalpy. So I can write like delta H, like delta H of reactant.
Mm-hmm.
Sorry, not reactant. Sorry, product minus delta H of reactant. So now let's put like this one. Product. So I'm writing the delta H of CaO plus delta H of CO2 and minus delta H of reactant, which is calcium carbonate. And I'm going to plug in the values. You already gave me calcium oxide is how much? Minus 635.6, right?
Yes.
Hello?
Yes. I'm just trying to. I'm writing it
And
down.
what about carbon dioxide? Minus 393.5. Minus 393.5. And I'm writing minus, this one is calcium carbonate is minus 1206.9. Minus 1206.9. 9 there. It is not allowing me to write 9. Okay, so I'm writing here. And now let's do this one. I am opening the parenthesis. Minus, plus minus will become minus. And minus minus will become positive. 1206.9. And let's solve this whole thing.
Okay.
Minus 635.6 minus 393.5 plus 1206.9, and I am getting 177.8 positive.
Yes. Yep.
And because the unit you gave me kilojoules per mole, so this is also going to be kilojoules per mole.
Hmm.
Is it clear?
Yes. Yep.
Is the answer is same?
I'm gonna check. We did 51, right?
Mm-hmm.
Yes. Correct.
Okay,
Correct.
so now let's go to the next one. What is the next number?
6.53.
6.53.
Yep. Heats of
Okay, let's do
combustion.
this. Mm.
So it's given me in part A 2H2 gas plus O2 gas.
Okay, so let's start the A part. And again, you have to go to the same appendix to give the values to me.
Yep.
So let's first write the H2. What is the heat of formation? O2 and H2O liquid. I think H2 is 0, I think.
H2 is
0.
0. Yep.
O2 is 0. O2 is also going to be 0. I know.
Yes. Yes.
Because for free element, the enthalpy of formation is 0. H2, O2, N2, like those things. Now for H2O, look the liquid because it is also going to be gas.
Mm-hmm.
You have to look the H2O liquid heat of formation.
Yeah. Negative
What is
285.8.
25.8 kilojoules per mole.
Yes.
Now be careful if you are water, look if they are writing liquid, then take that value. If it is gas, take that value. And now let's go to the thing equation 2H2 plus O2 gas and gives 2H2O liquid. Because your water is the product. So I'm writing the delta H of reaction, delta H of product minus delta H of reactant. Our product is H2O. But what is the coefficient of H2O?
2.
2. So write 2 times delta H of H2O liquid minus, and now because you have to write delta H of O2 H2, but you have to multiply it by twice,
Mm-hmm.
plus delta H of O2. Even I don't have to write because I know it is 0 0.
Right.
So 0 times 2, 0 times something, 0. So I'm just writing this one. 2 times H2O is minus 285.8, and I'm just plugging is 0, okay, because 0 times 2, 0 plus 0 is 0 is going to be. Now look this one and tell me the answer is this one.
Yeah, I'm just calculating it times. This one was 53. Negative 571.6. Yep. You're right.
Okay, you have the answer. For remember, even if you don't see there, and they don't give you delta H or heat of enthalpy of formation for free element like H2, O2, N2, they are all going to be 0.
Got it.
Okay, what next?
Next we got 6.57.
B part, right?
B. Sorry. Yep.
Okay, B part. First look the data again and give me the enthalpy of formation of all of them. Let me have a write the equation. B part.
Yep, 2C2H2.
2C2H2 like acetylene or ethylene, ethine, sorry, common name acetylene, C2H2 gas plus 5O2 gas gives 4CO2 gas plus 2H2O liquid. Okay. Now let's write the data first.
Yeah.
Let me write here instead of writing separately. What is the delta HF for this one? C2H2.
Yeah, it's the standard enthalpy of formation. Yeah, it doesn't have it in there, so I'm gonna have to look it up. It's given me an incomplete table. I'm gonna
Just write enthalpy of formation of ethylene. Oh, sorry, it's not ethylene, acetylene or ethine.
all right. Looks like it's 226.6 kilojoules.
How much you are saying?
Right? 650. Is this C2H2 is
Yes.
226.6?
226.6. Okay, I'm going to use that one.
And then for O2 is 0. Right?
O2 is going to be 0, definitely, yes.
Alright, and
So
then
let's do this thing.
yeah.
You told me like C2H2 is how much?
226.6
226.6 kilojoules per mole.
per mole.
This is going to be 0. What about CO2?
For CO2 is negative 393.5.
Kilojoules per mole. What about water liquid? We already did that, huh?
Negative 285.8.
285.8 kilojoules per mole. Okay, we have all things. I'm going directly doing that one. I'm writing the delta H of reaction is equal to delta H of product minus delta H of reactant. Delta H of product is because 4 CO2, so you write, I'm writing this one here. Delta H 4 times delta H of CO2 plus 2 times delta H of water liquid minus 2 times delta H of C2H2 minus 5 times delta H of O2. And now plug in the value. But make sure you are multiplying by the coefficient. So 4 times CO2 is how much? Minus 393.5 plus
2
2 times water, which is 285 point minus 285.8 minus 2 times 226.6 plus 5 times delta H of oxygen, which is 0. Sorry, this one I have to put 0 here. 5 times 0, which is 0. Now just do the calculation now.
Okay. 2598.8. Negative 2599.
How much you are getting? Hold on, just I haven't done. I have a mistake something. Hold on, 4 times minus 393.5 plus 2 times minus 285.8 minus 2 times 226.6 and minus, so this is, of course it doesn't matter, but it's minus. How much you are getting?
Negative 2599.
99, you are right. Okay. So that's going to be kilojoules.
Kilojoules.
Hmm,
Excuse me.
kilojoules. Okay, so that the answer is the same?
Yes. Yep.
Okay.
Yep.
So is it clear? So just take the enthalpy of product minus enthalpy of reactant. What next?
Let me see here. 6.57. Yeah.
6.57.
Do you want to stop after this next question? We'll give you some time to prepare for your next session. And then
Okay, no problem. We can
wanna do
stop
that?
here. 6.57.
0.57. Yep. Now I'll review everything that we've done from 4, 5, and 6 up to this point during this weekend
Okay.
while you're away, and then I think that we should meet up in the beginning of the week sometime if you're around. Only if you are around.
Yeah, I'm going to be only on tomorrow and day after that. Saturday, Sunday, I'm going to be not here. But after that, I'm going to be here. Okay, so no problem. Okay, 6.57.
Yep.
Find the standard enthalpies of formation, calculate delta H reaction. From the standard, okay. The same thing we have to do. C6. But whenever you are taking the values, be careful, you also have to take the values of the same state. If they are saying liquid, take it for the liquid because maybe the solid thing's value is different. Okay.
Got it. So it looks like
Plus
they're
902.
6 CO2 gas.
6CO2 gas plus 6H2O liquid because we need the state. They are already giving us the delta HF for C6H12 liquid is already given here, and this means standard minus 151.9 kilojoules per mole. What is the value of O2?
0.
0, you're right. What about CO2?
CO2 is negative 393.5.
Negative? What?
For CO2 gas,
Yeah.
negative 393.5.
Okay, kilojoules per mole. What about water? 285.
H2O liquid is negative 285.8.
Okay. We have all the information we need. So what we are going to do is delta H of reaction. Now you tell me what to do.
Yep. Delta H of the reaction is equal to the delta H of the products minus delta H of the reactants. So the products first, we have delta H of CO2. I'm sorry, yeah, CO2 is negative 393.5, and we have to multiply that by 6.
Okay. Yes, so I'm writing like this one. First I'm writing the formula. So 6 into delta H of CO2 plus 6 into delta H of water, right? Liquid.
Yes.
Minus delta H of C6H12 liquid minus delta H of O2. O2. And now plugging the value. For CO2 you already gave me 6 times
Negative.
minus 393.5 plus 6 times water is minus 285.8, and this one is minus 151.9 minus 0. Now let's do this thing. 6 times, in the parenthesis I am taking minus 393.5, closing the parenthesis, and now plus minus is going to minus into 285, and now minus 151.9. What is your answer?
Negative 3923.9.
Oh, maybe I am wrong, because I am getting something like this. Let me double check. Maybe I am wrong. 6 times minus 393.5 plus 6 times minus 285.8 minus 151.9. My answer is this much. Can you double check? Maybe I am wrong or you're something.
Yeah, the book is saying, negative 3924. I'm gonna see here. 6 times negative 393.5 plus 6 times negative 285.8 minus 151.9.
Oh, no. I think I made a mistake. I forget the sign of the minus one. 51. It's a minus, right?
Yeah, I just did this out and I did get this answer.
So it's going to be plus. That's going to be plus. Okay.
Plus, okay. Okay. Plus 151.9. Okay, yeah. Negative 3923.9. Yep.
Yes. Now it is clear. So there look, a little mistake in sign will give you the wrong answer. So always double check everything. Don't forget the sign, okay?
Oh, yeah.
Because missing the sign will give you completely wrong answer.
Got it. Yeah, he made it a point at the start of the lecture. He's like,
Yeah.
I'm gonna be
But you
testing.
can go and ask this question per mole thing.
Yeah.
Because if it is per mole, then we don't have to divide by 2. And if it is not per mole, then we have to divide by 2.
Got it. Yeah, that's definitely some tricky stuff. I definitely have to practice all these.
Okay.
Yeah, this was my most unfavorite section of the general chemistry 1 class. This one gave me trouble, but I have 2 weeks to improve on it. Cause the next exam is gonna be on Halloween, Thursday the
And I'm going to
31st.
send you like the one test for the thermochemistry.
Okay.
I want you to try those questions because not only the question which he gave you, but I'm going to give you some one test from this one. Okay?
Thank you, Jafri. I appreciate it.
Okay. Have a nice evening. Try,
You
take
too.
rest.
Oh yeah, I'm gonna take a nice rest, and I'm gonna wake up early tomorrow, and I got this is my first semester as a full-time student, so I'm taking 4 classes. So
Okay.
managing all the classes is something new for me. So yeah, I'm definitely gonna wake up tomorrow and get an early start to the day and practice all this stuff. So yeah,
Okay.
I'll reach out to you like Monday. I'll send you an email and we can coordinate something for the week. Okay.
Okay.
I really appreciate it, Jeff. You have a great day, a great
Okay.
weekend.
You too.
Thank you.
Okay. Bye.
Bye bye.